Hello ladies and gentlemen, and welcome to a little video where I talk about the motivation and how I implemented a component-aware document object model, or DOM for short. So if you are just here to see some code and want to know how I did it, I will put a timestamp in the description so you can jump right there. But first I want to talk about the motivation for it, because usually your, let's say, your root component doesn't necessarily need to be aware of all the other components, because they handle themselves in kind of way. So if you, let's say, are using them to render the DOM with OpenGL, so you just let every single component have its own draw call and handle its own drawing, or return some drawing information to a bigger drawing function that draws everything in one step. But in this case I have a different application in mind. Like if you want to create a web application, and that web application, the DOM of the web application that you have in your browser, needs to be replicated in a DOM in your code, in this example, your C++ code. So everything that changes in the DOM in your code, in your memory on your server, needs to also change in the browser. And if the user modifies in some way the DOM just by clicking or hovering over a component in the browser, then you need to be notified in your C++ code on the server. So there needs to be a message interchange of changes of both sides. And that's why you need your in this case it's a DOM, but more abstractly you need to be aware of every component inside your DOM. And I always, when I tried to implement it, I had the problem that you can't have circular dependencies in C++. You always have to choose one side, and the problem is a component needs to, if it is modified by, let's say, the click listener from a button, then it needs to notify your DOM or some kind of class that it has an attribute of it has changed. Maybe it's dropped out, it's been removed, its color changed, the text in it changed, or whatever you can imagine. And that needs to be communicated to a central point where it is made into a command, and this command is sent back to the client in the browser. On the other side is if the user clicks a button in the browser, then you can't just notify any click listener. You need to notify the click listener on this very button, and so you need to know this button. You can do this by giving the button in the client an ID, and if it's clicked, it sends to the server a message like the button with the ID whatever is clicked, and then your central component, your DOM or your root component, needs to know every single component in the tree to traverse it, and find the component, the button component in this case, to notify it that it has been clicked and fire a click event. Yeah, and that's the motivation. And it was usually the problem that first your component needs to be aware of the DOM, so it has it needed some kind of reference to your DOM or to message relay to send the message "I've been modified" out, but the DOM or this relay needed a reference to this component to tell it you've been modified, like in, let's say, click. And since both of those needed to know each other, I always had a problem with the, as I said, the circular dependency. And now coming to the solution to the problem is I created a triangle dependency where I have a relay that's just there for receiving messages from components. So every component has a relay pointer. Has a relay pointer, and it's a non-owning pointer in this case, so it's a raw pointer. I thought about using smart pointers, but in this case I think it's okay, because if a component is in a DOM, then there's always a relay. So this is either a valid pointer to something or it's a null pointer. And I can check for null pointers, so that shouldn't be a problem. Yeah, and this relay is for receiving messages and relaying, as the name suggests, the whatever happens in the component to our DOM here. And I did this with it's still not nice, I have to say, but it's the only solution I came up with. If you go in here and let's say you want to register a component, so this component here is let's say the root component. It's just an example implementation. You want to set child, so root component has only one child, and you say register on this relay pointer, and you put the unique pointer in it. I just move it in there. Oh no, it's just a reference, I'm sorry. And if you then receive the component, you get a new ID because you need to identify a component and call this add function. And this function, in this case, it's just implemented as a structure. So this variable is public. And while building the DOM in the constructor, you can see I set a new add function and put a simple lambda in there with everything that's known within this DOM is caught by reference. So I can use this index map to have a reference to this component. This is not complete, so because of course if you add a component, you also need to be able to remove a component. But just for examples, you just set the ID of the component, you give it a pointer to the relay, and as the DOM I own the relay. So I can freely dereference. It's not dereferencing. This is it's getting the address. That's it. Getting the address of the relay and just setting this class variable. Later, I think I will put some kind of protection to setting this relay, so the user can't reset the relay to another DOM he maybe has lying around. because a component should only have should be only inside no DOM or one DOM. Yeah. And then it's put in this map, because if you want to send a message to a component, you, as I said, need a reference, or in this case a pointer, to a component, and then send a command. In this case it's receive a command, because the component receives a command. In this case it's just a void function. It's a virtual function, so everything in here is done with runtime type information and polymorphism. I haven't found a nice solution without it, because I want the user to create custom components, and these need to have the exact same methods like the component, so they need to implement them, and as far as I know, there's only virtual functions for this. So that's it for the most part. Of course, the root is a component and it has no parent. It has only one child. Let's say you are an HTML DOM, what we are around roughly try to implement. Then the body is the place we want to work in. So yeah, we just set one child in it, and I made it a unique pointer to make use of in this case polymorphism. So it's just a unique pointer to component, and to have an example, I created a clickable component where I think it's overrode the receive command. So if we don't have a relay, then we do nothing, of course, but if we have one, then we say received click, and that's a method I just implemented for examples. Later this will be like something receive commands, so there will be a list of commands that the relay receives and will store in a list in itself, and will be made available to the DOM it's residing in. And then after you send a message and the DOM has been modified by the processing of the message inside the components, you can just grab these changes from the list in the relay and send it back to the client. And another thing that came to my mind that was quite a problem with the overall concept of the classes is, what if your user presses F5 or he loses connection and the server DOM goes out of sync with the client DOM? Then you need some kind of way to just refresh everything, and then you need to go through every single component, to get its current status. So are you hidden? Where are you placed? What are your child components? Where do I need to place those child components in? And all that stuff. And if you press F5, you need all that information to be iterable, I think is the fitting word. So you just would go through this index and say, okay, for every component in there, just give me your status information to rebuild the DOM on the client side. So yeah, so what I did in the main, I just created a DOM. The constructor should take care of most of it. Sadly, I think map is not const expr. I would have made my constructor const expr, and I think with C++20 there will be const expr virtual function calls, so I think everything I did in here, if map was const expr, I could do at compile time, but I might be also wrong. Nonetheless, I just the root is created inside the DOM automatically in the constructor, so just this command takes care of that. I can access the root, set a child, as seen above. That's gets moved inside the child variable, and the parent is set because every component except the root component needs a parent, and this component needs to be registered. I'm sorry. And it's just done by make unique, and since I make unique clickable, it's automatically converted, I think, to a unique pointer of component without any losses, I think, and hope so. I'm not all that proficient in polymorphism in C++. And then I just send a message to the component with the ID 1. So the root should be the component with the ID 0. And yeah, the next component is the child component. In this case, it's just the clickable component here, and it just can be clicked and send message to 1. So this send message to 1 imitates a user clicking on the clickable element in the client. So let's see what happens. I just run as a local C++ application, and yeah, it's not that great, but you see received click. That's on top in here in the relay. Usually here would be then printed a list of every command that was the result of the modification of the DOM, but in this case we just relayed the message in here to the corresponding component and said, now you received something. That's this one. This one fires, let's say, an event to the relay received click in here, and that's it. So if you go to Compiler Explorer and look at the assembly created, it's a lot. To be honest, it's a lot, and it works with polymorphism and runtime type information, so that's to be expected. I have no idea how the runtimes are, to be honest, but I think this is at least at the moment for my case satisfactory implementation for a component and aware document object model, where commands can be sent to components inside your tree, and components in the tree can return commands to your DOM that can be sent to the client. So everything is in sync. And I think that comes to a close for this video. If you kept through until this point, thank you. And I hope I could help you a little bit. And if you want to see the code, I have a gist with older code, not the nice names like these, but with older names, but with the same functionality. I will link it in the description. So until next time, bye.